All right, everybody, welcome to the video here for lesson number 10 on period and frequency of a sinusoidal function. So whenever we're determining the period or the frequency, we need to look at the equation and what's multiplied by x. So in this first equation, I see a frequency of 8. If the frequency is 8, I know that period times frequency equals 2 pi. So I'm asking myself, well, like what times 8 makes 2 pi? So I can do some quick algebra here. So p times 8 equals 2 pi, divide by 8. And I can say p is equal to pi over 4. So that's the period. Remember, the period is the horizontal distance it takes to complete one full cycle, where the frequency is how many full cycles you'd see between 0 and 2 pi. For the second one, the frequency is 2 pi over 7. So if I do frequency times period, I get 2 pi. So if I want to get rid of this, I'm going to multiply both sides by 7 over 2 pi to get rid of that 2 pi over 7. And luckily for me, the 2 pi's cancel, so we're left with a period of 7. For the next one, the frequency is 4/3. So if I do period times 4/3 equals 2 pi, again, we want to multiply by 3/4, the reciprocal, to get rid of it. And it's totally okay if the period and or the frequency have pi in it. We just leave it in terms of pi. So this becomes 6 pi over 4, which we can even reduce to 3 pi over 2. Number 2 says a sine curve has a period of 2 pi over 7. Determine the frequency. So if I have 2 pi over 7 times the frequency equals 2 pi, I can multiply by 7 over 2 pi on both sides. The 2 pi's will cancel, and the frequency would be 7. So what that means is there would be 7 sine curves between 0 and 2 pi. Number 3 says a child is on a swing. It takes the child 2 minutes to swing back and forth 30 times, right? So here's your swing, all right? So it's going back and forth 30 times. Back and forth is one cycle. So if it takes 2 minutes to go back and forth 30 times, it takes 2 minutes to do 30 cycles. So if I want to figure out how long it takes to make one cycle, I could take 2 minutes and divide it by 30, and I would get 1/15 of a minute per cycle, which is the period, because it says everything is in terms of minutes. Then it says state the period and frequency. So I know the period. So let's find the frequency. So I'd say 1/15 times b equals 2 pi. So the frequency, if I multiply both sides by 15, frequency is 30 pi. So we're just figuring out how long does it take to make one cycle. That's it. Whoops. That's what I just did there. Zoomed in. Shouldn't have zoomed in. All right, so let's take a look at number 4. Number 4 says write an equation of a sine function with an amplitude of 2, a period of pi over 2, and a midline of y equals -3. So remember, period helps you for the graph. It does not help you for the equation. So the first thing I have to do is I have to figure out, well, what is the b value? What is the frequency? Multiply this by 2 over pi. Pi's cancel, and I'm left with a frequency of 4. So my equation I can show as f of x. Looks bad. Let me fix that. All right, let's say f of x equals, amplitude is 2 sine of 4x minus 3. Right? Remember, the amplitude is what goes up front, the frequency is what goes inside, and the k value, or the midline, is what goes on the outside subtracted. There's your answer. Then it says to sketch one cycle of the curve below, right? So since it just wants one cycle, I totally could go out 4 boxes like I might have done in class, but in this case, I'm going to go out 8 boxes. So that when I separate, I'm going to go That would be 9 boxes. Let's count correctly. So if I go 8 boxes, when I separate, I could still make my quarter turns like normal, but I'm kind of just stretching it a little bit so it makes it look nicer. You do not have to do this, okay? Since the period is pi over 2, I'm going to put pi over 2 over here. And since the midline is -3, I'm going to make a dotted line at y equals -3. Since it is a sine curve, I know I'm going to start at the midline. And I made it have a non-reflection, so amplitude of 2, I'm going to go up 2. So after a quarter turn, I'm going to go up 2. Half turn, sine curves are back at the midline. 3/4 of a turn, I'm going to go down to the minimum value, so I'll go down 2. Remember, I'm oscillating up and down by 2. And then I'm going to go back to the midline to end my cycle. So again, this cycle is going to go in 4 turns, right? Quarter turn, half turn, 3/4 turn, full turn. Now, if you did it and you just want 4 boxes, it's the same curve, just kind of scrunched together, and that's it. Now, I know in one of my classes, I asked you to finish 2 questions from the notes, so we didn't get a chance to do C and D. And in my other class, I asked you to write the equation of the opening exercise. So I'm going to do both of those things, right? So for C, it says the number of hours of daylight over the year in terms of days. Well, I know in the winter solstice, that's telling me that's the least number of days of the year, hours of daylight in the year. And the summer solstice is the most. So it's going to take a half of a year to go from the minimum to the maximum. So it must take a full year to go through the entire cycle. So the period is 365, which means the frequency is going to be 365 divided by 2 pi. And that's not right. Let's do this again. So P, so 365 times B equals 2 pi. Divide 365. Don't try and get fancy like I did. Do the algebra so we don't make mistakes. So we wind up having 2 pi over 365. Part D says a pendulum swings back and forth 4 times every 6 seconds. So that means the p-value is going to be 6 seconds divided by 4 cycles. So that's going to be 1.5 seconds per cycle. So the period, we can say, is 3/2. I like fractions better than decimals. So if I want to figure out the frequency, I would do 3/2 times B equals 2 pi. Multiply by 2/3 to get rid of that. 2/3 to get rid of that. So we get B equals 4 pi over 3. And for my other class, the one that had to do something with the opening exercise, let's go back here to the opening exercise. So in class, we graphed this. So we had 0, 13, 26, 20, 10, 5, and 15. We showed all of these points. We talked about how it's not a parabola, so it's going to be curved and look something like a bell. So since the period is 20, to find the frequency, I would do 20b equals 2 pi, or b is equal to pi over 10. This has a midline of 13, an amplitude of 13, and it's an upside down cosine curve. So I'd say y equals -13, the negative to turn it upside down, cosine of pi over 10x plus 13. There's your equation for the opening exercise if you're in my period 5 class. Good luck with our homework. If you're one of my Regents kids, I know I've been talking about some differences that we did here. All that stuff here is useful for you too. All right, so just keep watching the videos. Hopefully it all helps. Good luck with your homework.